Our next speaker is Eva Deelman, Principal Investigator from CI Compass. She's here to talk about navigating the U.S. National Science Foundation's major and mid-scale facilities data lifecycle. Just a reminder that there are microphones on the floor if you have any questions at any point for any of our speakers. Donc, un rappel qu'il y a 2 micros ici à la salle que vous pouvez utiliser pour poser des questions aux panélistes et présentateurs. Without further ado, Eva?
Thank you very much. It's really a pleasure to be here to learn about the major facilities in Canada, and I look forward to meeting all of you during, or most of you at least, during these next 2 days. And thank you very much for the Canadian Foundation for Innovation for inviting me to be here. So I'm the PI of CI Compass, which is a NSF-funded Cyberinfrastructure Center of Excellence, and I'm located at the University of Southern California. So our mission is to provide expertise and active support to cyberinfrastructure practitioners at the NSF major and mid-scale facilities in order to accelerate the data lifecycle. Sorry, trying to get that microphone. Okay. To make sure that basically the integrity and effectiveness of the cyber infrastructure that underlies the major facilities can be dependable and produce scientific results. So this is a graphic from the National Science Foundation, which shows a variety of different major facilities across the US. And they reach basically from the ocean to Earth to the universe, very similar to the facilities here in Canada. They look at samples at small scales and the universe at the larger scale. And one difference that I saw from the facilities that you have here is that it doesn't deal with human health, for example. And this is because this is outside of a National Science Foundation mission. This is in the realm of NIH. But outside of that, it does science across a number of different disciplines. So although these different facilities are very diverse, as part of CI Compass, we aim to characterize the data lifecycle and anchor our work in that data lifecycle so we can then engage with facilities at that level. So if you look at the cycle, we basically start from the data collection at the instruments. So this could be a telescope, this could be a buoy in the ocean, this could be a wind facility like with these various sensors like we heard about this morning. There's some initial data processing that's happening close to the sensor, so maybe some quick calculations or some quality, checking the quality of the data that's coming off the instruments. Then the data is usually shipped to a central processing facility, so it's a data center where additional science data products are being generated. And then the data is curated, stored, and archived. From there, the data is then published to the community, to the scientists, to the educators and the public. And so there are various portals and visualizations that are available to the scientists and the general public to look at. There are also some cross-cutting issues within the data lifecycle. So it's data movement, for example, so moving the data across these various stages and to the end users. There are issues of fair data, so how do you tag the data from the time it's being collected at the instruments to the time that's being disseminated to the users. And then there are also issues of identity management, so you can allow access to the infrastructures, but also track the data usage. So in terms of this the data lifecycle, not all the facilities follow all these exact steps. There's also cycles within that, but this allows us at least to talk to the facilities and think about how this cyber infrastructure needs to be put in place in order to support the various stages. So in terms of what we do at CI Compass, we help evaluate cyber infrastructure plans. We help architect new solutions, working very closely with the major facilities. We develop proof of concepts. So, for example, if new technologies come online, we can develop quick proof of concepts to see how these technologies would be applicable to particular data or challenges within a major facility. We don't do any software development, so we're not a coding shop. We provide advice, and we basically help the facilities leverage existing solutions out there. So who we are, so we basically, to support this entire data lifecycle, we assembled a team of people with various expertise. So we have expertise in data management, data processing, visualization, archiving, and semantic technologies. On my expertise is in the area of automation and distributed systems, scientific workflows. We also have expertise in folks that work with sensor data, networking. Clouds are also being looked at as an option for data centers for the major facilities. We also have expertise in deploying large-scale cyber infrastructure and operating it. One thing that I think maybe distinguishes us from some projects is that we have also social scientists on our team that looks at organizational issues and how the major facilities work. For example, he did a study on how the major facilities responded to the pandemic, what were the practices that were useful to them. And then we also have experience in the management of cyber infrastructure project, from conceptualization, design to their adoption. We have project management expertise. I think what keeps us all together is that we are very collaborative. We work with each other, but we also work within the computer science cyber infrastructure community, and also more broadly. So we're part of various organizations such as Research Data Alliance, MSIF, which is focused on earth sciences, and others. And as part of coming together as center, we also distilled a number of core values by which we operate and which guide our decision-making. In terms of the various activities that we have, so we engage one-on-one with the major facilities. So this is the case, and I'll give some examples of those, but basically a major facility would come to us with a particular problem or a challenge that they have, and would develop an engagement plan of how we're going to work together, and the products of that engagement. So it can be, these type of engagements can be multi-month, multi-year. We also have engagements that are just a short phone call to resolve issues, and obviously no plans are made for that. These engagements are between us and the major facility, so we keep that information confidential unless the major facility wants to use it for their own purposes. Oftentimes we share it, for example, with their advisory committees and also with the National Science Foundation if it's to the benefit. So in some cases, the issues that are pertinent to major facilities cross the facilities, so they're common across them. So we form topical working groups around these topics and invite the major facilities and also cyber infrastructure professionals. These are open groups, so anybody can participate to discuss these topics. And I'll give some examples of that. We also conduct workshops. Every 2 years, we have a cyber infrastructure for major facilities workshop. And in between, we also have virtual workshops, which I'll talk about as well. We have a student program for undergraduate students, and I'll go into more details about that, and also webinars and others. So this is an example of an engagement that we had with research vessels, regional class research vessels. That was back in 2022. These vessels are being designed currently, and hopefully some of them will be coming out soon. And we basically did a review of a network that we're planning to have on board, and we saw that some of the switches were underpowered, and we recommended increasing the capability of these switches. So this was before the network was actually put into the ships. This was at the design stage. And interestingly enough, the research vessels are being led out of Oregon State University. At that time that the researchers were working on the network, the Sikuliak vessel, which is an Arctic going ship, also came into port in Oregon and confirmed that actually they found that the switches that they had, which was at the same time as originally planned by RCRV, were underpowered, and they had to improve their networks, which came to actually be very beneficial to the scientists themselves. So, so this was a nice confirmation of this engagement findings. Another example comes from MagLab. So this is a large magnet facility in Florida. And this is a little bit more complicated. So basically, the way this facility operates is that the PIs, the scientists, come to the facility and they conduct the experiments using the magnets that are available there. The issue is that MagLab wants to be able to make it easier for the PIs to share the data after they have conducted the experiment. So, but the challenge is that these experiments are very complicated because the metadata comes from the configuration of the magnet. Additionally, the scientists pull off the shelves additional instruments to compose the experiment. They also might bring their own equipment to do the experimentation. So now you have 3 different moving parts that come into play. These things can be configured in a variety of ways. And additionally, the samples that are being studied also are often grown by somebody else rather than the PI. So you can see that this, and I'm sure many of you understand the complexity of how do you capture the metadata so that the PI can then share this data with the colleagues or with the public. So this is obviously an issue that's beyond just MagLab and CI Compass. So we engage in this process, we're also engaging other partners, so the Research Data Alliance, and looking at schema.org and how it can support information about the instruments. We also engage with Earth Science Information Partners, ESIP, to look at basically providing information about the needs of scientific experiments such as MagLab. And so also as part of that, we have brought together a FAIR Data Working Group. So this is a topical working group which facilitates the conversations about FAIR issues. The facilities share their best practices. We also bring in others that, for example, from a NSF FAIR Open Science Research Coordination Network Group to participate in the discussion. So basically, we're trying to build a community around issues of FAIR, and I hope that some of you here would participate in our discussions. We also have other working groups, so one that has sunsetted, which was the Identity Management Working Group. They developed an identity management cookbook, so you can follow basically this cookbook and try to implement your identity management solutions. We also have an active cloud infrastructure working group, which looks at what are the challenges of moving major facilities moving to the cloud? So what are the questions you need to ask yourself about the cost, but also technologies and other aspects of cloud migration? And they generated a report last year about this particular topic. And we're also thinking about creating a group for the data lifecycle to generate a guidebook on the topic. So in addition to the working groups, we also have various technical notes that we generate based on our work. And all of this is available on our CI Compass website. We also generate the proof of concepts that we generate are also placed for use by the community in GitHub. Webinars, so we have representatives of major and mid-scale facilities talking about their work of a particular topic. So like, for example, an NMR mid-scale, Chris Bontempi talked about flexible data engineering pipelines. We had presentations from NSF on open science last year. We also had a presentation on Design Safe, which works with a national hazard major infrastructures in the US, talking about how they manage the data on behalf of these experimental facilities, and also other types of webinars, and I encourage you to go to our website if you're interested in that. We also have an undergraduate student fellowship program, of which we're very proud of. It has two, and it kind of goes towards the previous panel of broadening participation in cyber infrastructure work, particularly for science projects. And so this program has two aspects. It has the virtual spring program where you have students coming to virtually coming together in form of a classroom. We're actually doing a reverse classroom, and they learn about cyber infrastructure. They learn about the data lifecycle within the major facilities, and this is meant to be kind of it's a 12-week program, and it's meant to be a virtual course. And if students have a faculty mentor off campus, they can get course credit for that particular activity. We also have some students that just audit the class as well. We also have an optional summer program where we place students within the major and mid-scale facilities to do research over the period of 7 weeks in the summer. Again, it can be both virtual or in person. We encourage in person. If the students cannot travel and it's a virtual program, at least we ask them to visit the facility maybe for a week during the summer. All students also get a scholarship to go to a conference of their choice. And every year we have about 20 students that are selected out of 120 or 130 applications. This is I'll give you a brief view of a curriculum. So in blue, you have technical portions. In green, you have research portions that focus on the data lifecycle. We also have a component where we have major and mid-scale facilities giving talks to the students, and these are very well received. So basically, the students see how have the ability to talk to people, to the professionals within the facilities, and learn about how it is to be a member of these science teams. At the end, also they make presentations about a particular major facilities, working with them, finding out a bit about the data lifecycle. I'll just show some of the impact here. You can read it, but basically for us, it's exposure. Just as a conversation was going on earlier, it's not so much about the outcome that somebody learns everything there is to know about cyber infrastructure. That's not possible in that time frame. But we want to expose the students to opportunities, career opportunities within the science field and cyber infrastructure. Typically, they come into us, and we take from first-year undergrad to super senior, so sometimes they come into us thinking that it's only Facebook and Google that are out there, and we want to show them that there are other career paths as well. We also conduct virtual workshops. So we had a workshop a couple weeks ago on the first part of the data lifecycle, from instrument to first storage, and we had participations from Ocean Networks Canada, who talked about the Ben talked about the project, and particularly also about this initial data lifecycle. All the presentations, the slides are now on our website, and we also will have the videos of that as well. Finally, there's also a workshop coming up that is organized by the National Science Foundation. It's going to be near Los Angeles. And you can see there are a variety of topics that we are planning to address within our cyber infrastructure track. So looking at the issues of AI, what is your thinking about AI? How are you preparing for AI? Are you thinking about making your data AI ready? How do you track data usage? How much value do you place on user experience when you share the data? How do you integrate new technologies into your CI environment? Obviously, things are changing over time. Basically, we welcome discussion and participation on these issues. So being here, I really look forward to establishing some collaborations with you. So we can have discussions around the data lifecycle, so issues of fair data, instrument identifiers, data archival, and cloud adoption. These are the topics that are part of our topical working groups. Obviously, always handling large data sizes, the data sets which keep growing is a topic of interest to all of us, and real-time data requirements, so pushing data from South America, for example, back to the US. Preparing research infrastructures for AI, beyond just ChatGPT. I was visiting Seculac last week, and yes, ChatGPT is used on board by the scientists, but we're also thinking about other things and how can we prepare for that. Developing cyberinfrastructure plans is also a topic for discussion. Sharing best practices on what to do and what not to do is also something we can work on together, and we can have one-on-one discussion, group discussion, participation in our working groups, so webinars or events. I would welcome people presenting at our webinars. Collaboration on this student curriculum, so this is something that we keep evolving and want to understand what's needed. And potentially student internships, so that's something that we can explore as well, and any others that people are interested in. And I'm out of time, and I kind of ate up the question time as well, so I apologize, but please connect with us. You also are more than welcome to connect with me directly via email on LinkedIn, and I look forward to our discussions today. Thank you.
La prochaine partie de notre ordre du jour, en fait, va avoir lieu à deux endroits différents. Donc, dans la salle ici, nous allons avoir une mise à jour du comité des données du FISM. Mais en même temps, il y a une discussion avec le service des finances de la FCI qui a lieu au salon dans la salle de conférence numéro 2. So just to let you know that the next part of our workshop is actually taking place in two different locations depending on what is of interest to you. So in this room, we're going to be providing an update on the MSIF Data Working Group. Meanwhile, starting in about 5 minutes, we will have a discussion with the finance team to share finance-related experiences, and that is taking place in meeting room number 2. So if you're looking for meeting room number 2, si vous cherchez la salle de conférence numéro 2, par la porte, et ma collègue Cynthia est là et elle va vous diriger, c'est vers la droite à l'étage. Donc, the meeting with our friends from finance is taking place out the door, on your right, on the first floor. And now for what is happening in this room. We will now proceed with a discussion on the update on the MSIF Data Working Group, data lifecycles needs of research facilities funded through the MSIF. And our speaker for this is Naveed Aziz, who is the chair of the MSIF Data Working Group. Naveed, are you here? Ah, there he is. Alors, en attendant que Naveed arrive, donc la discussion maintenant va poursuivre sur le travail du groupe de travail sur les données et notre présentateur est Naveed Aziz. Thank you, Naveed.
My name is Naveed Aziz. I'm currently working as the Vice President Research and Innovation for Genome Canada. I do have a close link and very close to my heart link with the MSIs, but I think I'll talk about it a little bit more later on when we talk about the panel. But for right now, I'm pleased to provide an update on the progress of the MSI Data Working Group over the past 1 year. I'd like to highlight some critical data lifecycle needs that were identified by the working group and by the community, and highlight some of the challenges faced by the MSI-funded research facilities. So I best, if I collect green, it should change. Yes, perfect. So in terms of purpose and objectives, CFI recognizes that MSI-funded facilities manage diverse and complex data across disciplines. And it really aims to foster knowledge sharing and best practice in data lifecycle management, and to help identify effective data management practices for large facilities, including defining and understanding the role of partners like the Digital Research Alliance of Canada, CANARY, and others. In terms of the mandate, with that in kind of the idea in mind of data lifecycle, CFI assembled a working group. The role of the working group was to advise and provide strategic guidance on data governance and infrastructure that supports the data lifecycle model, to work with partners and service providers to address challenges and report back to CFI and the MSI community. In terms of the working group itself, we are 8 members, myself as the chair, and then there are other key MSI leads as member of the working group. I think it was mentioned this morning, but I will take a second again and recognize Catherine Williams, who unfortunately passed away earlier this year. Catherine was part of our working group, an amazing researcher, genuinely kind individual, and really left a lasting impression on everybody who had the pleasure to meeting Catherine. I knew Catherine personally as well and got to know her over the years, working through the MSI, various MSI meetings. Just seen another colleague that I haven't seen for a long time. Just an amazing individual, and what a loss for Canada and what a loss for the international research community as well. So in terms of the working group, in terms of focus, we took a two-pronged approach. There was the working group, 8 of us discussing, bringing some of the challenges and ideas to the discussion at our working group meetings over the year. But we also decided, with the help of CFI, to get a wider survey out to all MSIs and get some opinion and advice around their challenges and their opportunities that they see from the data working group. So I'll take a moment just to talk about the two-pronged approach and a little bit about the two areas that were discussed, and then I'll bring it together again at some of the early findings that we have. So in terms of the working group and the need assessment by the working group, one of the most substantial discussion that happened at the working group was around the implication of data practices and policies on service provision and delivering the facility mandate. There was a recognition that in the absence of some of the data management practices and policies, it became harder for the MSIs to deliver on their mandate and provide the service that they were supposed to provide. The working group also identified the need for open source tools and technologies versus licensing. So some of the MSIs are using open source software for their technology needs, others are licensing, and there was a discussion discussion around potential lack of economies of scales and working together to get some of these licensing deals done on tools and technologies that the MSIs are using. Other topic raised from sharing and coordination of data, as you can probably guess. Data sovereignty came up again and again, and safeguarding of national interest came up again and again for the data from all the MSIs. And in terms of the survey, we conducted a community-wide survey to gather perspective on data management and governance. Some of the questions that we use for the survey are up on the slides right now. The survey was really to assess the importance of various needs and the current level of service provided and the operational solutions. CFI evaluation team has evaluated the survey, and the plan is to release the results of the survey in the next couple of weeks to the community for you to dig deeper into it. I wouldn't have time to go through all the data that we have received from the community, but it is a rich source of information for all of us to not only see collectively what the MSIs are saying around their challenges and opportunities, but also to see if there are areas of common interest that the MSIs can work together on related to data. So to come to the real meat of my update for today. Through our discussions and the survey findings, there are some early ideas, and we have identified 3 critical areas that require immediate attention. First, secure data storage and cybersecurity remains top priorities, as you can imagine. Facilities need reliable storage that balances on-site activity with scalable cloud access. Many also lack essential backup solutions, increases risk to the research community. Second, advanced analytical and AI capabilities are increasingly critical as facilities generate massive data sets. Researchers need better tools to extract insights efficiently, yet many struggle with limited computing resource. Third, long-term data retention and archival digitization are growing concerns. Some research data sets must be preserved for decades, but funding cycles don't always align with long-term responsibility of maintaining access to critical data. Beyond these needs, facilities reported other significant challenges, particularly in terms of availability or lack thereof of national storage infrastructure. There's also a need for clarity on the role played by supporting partners like DRAC and Canary, and concerns around accessibility were also mentioned repeatedly in the survey. Noting that research data volumes are rapidly expanding, yet current storage and processing capabilities are struggling to keep up with scalability and is a challenge. Looking ahead, I think the working group focused on 3 emerging priority areas. The MSIF working group is advocating for more flexible facility-level service agreements, ensuring facilities have direct access to the resource they need rather than relying on fragmented allocation of systems. They are also pushing for improved disaster recovery and cybersecurity support, addressing concerns about data protection and resilience. Finally, there is a specific recognition around the need for better national coordination, ensuring that Canada's data strategy aligns with the evolving demands of our research ecosystem. So in closing, I'd say that our findings also underscore the urgent need to address data lifecycle challenges for MSI facilities. As the next step, the working group will focus on how the MSI infrastructure can provide scalable and secure solutions by improving coordination within the MSI facilities of varying sizes and scale, and what role can CFI and other partners play in making sure that MSI are able to empower Canada's research community to thrive. So that was a quick report. As I said, the larger report on the survey will be released to the community in the next few weeks. The working group will continue to work on advancing some of these findings of the survey and discussions, and I'm very sure that we will take some of the important issues and challenges facing the MSIs from today, and we bring that into our conversation. The panel immediately followed after this one is also an important one around data, and I'm sure that there will be discussions that will be relevant to this in that panel as well. And I'll stop here. I know I finished quickly. If anybody has any questions, I'm happy to answer, to give you a bit more insight on the working group, how the working group was working. If not, a lot of the questions I said could also be posed to the panel, who are a lot more clever people than I am on the panel. Thank you.
So, any questions for our presenter? Question? No? Well, thank you very much. Okay. Moving right along, thank you again for keeping the time. We're doing very well in terms of all the presenters and presentations to date. The next part of our workshop considers facilities funded through the MSIF in the context of the National Data Governance Framework. I will invite our moderator, David Castle, donc le facilitateur de la session, David Castle, who is the chair of SuperDARN National Advisory Committee. Les panélistes sont Natalie Harrower, from the executive director of CRDCN, Benoit Pirenne, Chief Innovation and Technology Officer, Oceans Network Canada, and Shuvijan Ratnasingham, Director of IT and Informatics at the Center for Biodiversity Genomics. If all the presenters and moderator can join us up on stage.
So welcome everyone to this panel. And I think what we are going to do initially is just to give a proper introduction of ourselves to you. And then I'm going to say a few things about the work that we've been doing in the Office of the Chief Science Advisor around a data governance framework. And then we are going to use that as an opportunity to raise a couple of questions about data infrastructures and the MSIs or MRFs, which my three colleagues will respond to, but then those are meant to actually be provocations to actually have a bigger conversation about the issues of data and these research infrastructures. So just in the order that you're here, I think we should just have an introduction.
Sure.
If you want to go again,
Naveed Aziz, Genome Canada VP Research and Innovation. What I didn't say earlier was that my connection to the MSI, that until a year ago, I was the CEO of CGen, which Meredith was on the panel earlier. I was the inaugural CEO of CGen and did that for about 7 years. So familiar with obviously MSIs very well, and know many of you in the room in that capacity as well.
Great, thanks. Benoit?
Yeah, my name is Benoit Pirenne. Bonjour. I'm the Chief Innovation and Technology Officer for Ocean Networks Canada. I've had a career mostly in data management through the last so many decades now already. And I guess that's kind of why I'm here and continue to talk about data, despite the fact that it's not necessarily now part of my day-to-day responsibility. Some of my colleagues here will do that for me. I will not have to talk about Ocean Networks Canada because my other colleague, Daniela, did a great job this morning already. And so I think I'll move on to my colleague to my left.
Yep. Good morning, everybody. My name is Natalie Harrower. So I'm the Executive Director of the CRDCN, which is the Canadian Research Data Centre Network. We are hosted by McMaster University, but we have a collaboration, and it's a collaboration between Statistics Canada and now 46 of the universities across the country in all of the provinces. And I, like Benoit, also have a background in data management from a variety of different perspectives, in particular around fair data. So I was interested to hear our colleague from the United States speak about their work in that. And I guess one thing I just want to note about our research infrastructure is that we are hitting 25 this year. It's our 25th birthday, which I think is a fairly long-standing period of time. And last year we released a new strategic plan, which is strategically placed at the front door for you to pick up and take a look at. So that's what it looks like. Curious to hear any thoughts on that.
Great, thanks Natalie. Yeah. And yes, so I'm David Castle. I am allegedly a professor at the University of Victoria, where I spend actually almost no time whatsoever, because I'm out doing other things on behalf of the university. But for the last 4 years, I've been working directly to the Chief Science Advisor to the Prime Minister and Cabinet, Dr. Mona Niemer, and I advise her on data governance questions, open science, research security. Sorry about the research security stuff, by the way. I had a hand in that. And also biodiversity data. So I do all of that, but I have a number of different other sort of hats that I think are probably worth sort of mentioning here. It's not really a disclosure comment, but it'll, I think, help you understand where we're coming from a little bit with this particular report that I'll describe in a moment. So I've had a lot of interaction with CFI-enabled research infrastructures over the years. I am the chair of the advisory committee for SuperDarn Canada, and thank you for your kind words previously, Naveed, about Catherine McWilliams, who unfortunately passed away at the beginning of this year, and it's been a rather grueling exercise as the chair of the advisory committee to have to send out such bad news to the broader community, but also actually deeply heartwarming to hear all of the very positive messages that came back about Catherine and what a great person she was and her scientific leadership. Greatly missed. So I continue to serve SuperDarn. I have been for many, many years involved in the barcode of life work that's at the Center for Biodiversity Genomics, and I see Paul Hébert is here, of course. And so we've worked around this major infrastructure for a very long time. I used to be the vice chair of the board of management for Triumph, so I know the Triumph folks very well. I was VP research at UVic for a number of years, and I was therefore overseeing Ocean Networks Canada for many years, and worked very closely with Benoit and the rest of the ONC team, and so on and so forth. So I've been around the block on research infrastructure for a number of years, and in fact, partly because of that, I've started some years back to work on behalf of the International Science Council. I run the scientific committee for the World Data System, which is a network of members, about 130 of which are running major research data repositories around the world. And through that work, Benoit and I, a number of years ago, set up an office at ONC, University of Victoria, which is an international technology office which provides services both in Canada but to our WDS membership around the world, and that's supported by the Digital Research Alliance of Canada. And I was a little bit late coming in this morning because we have an international programs office associated with the World Data System, which is funded by the Department of Energy. And is based at the Oak Ridge National Laboratory in Tennessee. We had to have an emergency call this morning just about funding matters in the United States. So I was not able to attend the first sessions of the morning, but it sort of underscores to me some of what I'm going to describe in this report about the vulnerability and the fragility, I think, that is associated with funding related to data and data infrastructures. It's a lot easier to say we need money for high-performance computing because of AI than it is to say we actually really need to attend to our data infrastructures. That just puts people to sleep for whatever reason. And I think it has something to do with the fact that there's still a lingering association between funders and data infrastructures where they think that data for science is kind of like the way that the internet works. You can just go find it, right? And it's always there, and you just access it for free. But data infrastructures are not like that, and data actually has to be very carefully curated and securitized and given very clear access points and so on and so forth. So it's actually a very significant part of what has to happen is management of these infrastructures. So all of which is to say, we are going to actually speak specifically in this session about why data infrastructures are crucial and why they actually matter deeply in the MSI-MRF context, and a few remarks along the way related to this particular report about how we should actually govern this system. So here's the context for the way that this report emerged, which is in February 2020, we launched the Roadmap for Open Science. So this was a 9-recommendation roadmap that came out of the Office of the Chief Science Advisor, and it had a number of recommendations related to doing things like creating centralized repositories within the federal government for federal government science to actually be collected into a single repository, so we were doing things like that. We wrote a report about how you actually manage open by default and what does that actually mean, and we provided recommendations about how to guide your way through decision making about when things can't actually be open or they at least have to be restricted and how you make those decisions, and so on and so forth. So we've been working away on this for quite a long time. One of the recommendations, though, that we had not actually conquered, which was the 9th recommendation, it was actually the 5th, but it was the 9th to actually get executed. The 5th recommendation we had actually just not done for various reasons, and it was actually quite focused. It was actually about getting science-based departments and agencies within the federal system to start actually gravitating towards development and utilization of fair data standards within those departments and agencies. And so what we were thinking about in that respect is that once we actually were creating a federal government repository, we thought, well, that repository therefore should actually embrace the FAIR principles, and all the data going in and out of it should be managed accordingly. So this was a fairly narrow recommendation that we needed to accomplish, and I'll explain in a second how it got expanded. But our approach to this then was to develop an advisory committee on Canadian scientific data governance. You can find all of this on the Chief Science Advisor's website. It's all up there. So we created this advisory committee to actually look into what a data governance framework actually might look like for Canada. So you can see there that I had a co-chair in Amy Buckland, who is the University librarian at Concordia, but she was a former ADM in Heritage, and she actually worked very closely as the 2IC to the chief librarian at Library and Archives Canada. So she actually understands the entire library space, both within government but also in university research contexts. Other people here, many of you will know people like Mark Daly at Western, Monica Granados, Natalie, of course, here, Kevin Casa, who is a Master of Applied Sciences student from University of Guelph and the Vector Institute, Lee Wilson, who eventually replaced Mark Leggett, Kim McGrail, my colleague out west, who's interested in health data, Benoit, of course, Eric Rancourt from StatsCan. Sujeevan is the architect of the BOLD and EMBRAVE systems at the Center for Biodiversity Genomics at the University of Guelph. Unfortunately, he can't be here today. We had him on the slate, but other matters arose. Kathleen Shearer from COAR, and Reda is at SFU, but he's actually the department head for scientific computing at Triumph. Bo, who is now retired, was the CIO at the University of Toronto, and a great contributor to the sort of data landscape in Canada. And Peter Williams, who now also retired. Something about this committee seemed to have made a lot of people retire. I don't know what we did to them. But Peter was vice president of cybersecurity programs at Canary. So interesting group of people, lots of really great conversation that we had with them. So here's where I will loop back to what I said a moment ago, which is that recommendation 5 that we were working on sounded like it was just going to be about fair data for government science. But we decided, at the urging of the chief librarian, Leslie Weir, to think a little bit more broadly so that we weren't just thinking about government science, but we could think about government science, funded research, and then other things that would appear in context of libraries where actually even like physical artifacts end up actually having essentially a digital copy. And so collections as data was also part of what we were trying to think about. In a ways that we would then be able to have a sort of broader remit and not get bogged down in specific data contexts or specific data uses, but we were thinking a little bit more laterally. So echoing some of my colleagues at University of Leiden, we basically, in generic terms, we're really thinking about real-world data, so it could be regulatory data, observational data, established knowledge. Those could be things in archives or just things that you refer to as a matter of custom in the body of knowledge that you're drawing from, and then experimental data. So we just use these 3 very generic sort of buckets to talk about the different kinds of data that we were thinking about. And then to contextualize them, we started working on a basis of thinking about where data arises from, and this is this data centricity point that you were making. We were thinking a data-centric viewpoint where you're actually trying to follow data from its creation all the way through the life cycle of data, and there are many different life cycle models that you can refer to. But we were interested in understanding what are the contexts in which that data actually arises. So we generically called it data domains. We're aware, of course, that the Digital Research Alliance is speaking more about data spaces. We may end up actually just opting for data spaces in the final version of this report. Obviously, that echoes as well what's going on in the European context, where data spaces are not only about just where data arises and how it's actually used, but it's ultimately intended to map all the way onto industrial sectors in the European context, which is further than what Canada is doing now, and certainly further than what we were thinking about in writing this report. So that's why we held back a little bit and said data domains, but I think we'll probably say spaces ultimately. And these are just these are the spheres where data is produced, bounded domains characterized by subject matter. Maybe it's like astrophysics or something like that, and communities of practice and how people actually organize their work according to disciplines. All right, set up the committee, give ourselves our little marching order for what we were going to do. We've been at this for a little bit over a year. Where we're at right now is the roughly 20-page draft report has gone to the chief science advisor and back out, and it turns out it's a case that if I had had more time, I would have written a shorter report. And now I've been given the time to actually write that shorter report by the chief science advisor. So as of the end of this week or early next week, our condensed version of the report will go back to Dr. Niemer, and from there we hope that we'll be able to publish it in a couple of weeks. Obviously, French and English, putting it on the website, graphic design, and all that stuff will take a little bit of time. So we've been meeting with our advisory committee periodically. We've been getting advisory committee feedback. We've gone to ADM tables. We've gone to deputy minister tables. I've done a bunch of informal consultations, sometimes with my colleague Amy and my colleague Alex at the office. So we've talked on and off with the Digital Research Alliance. We've talked to Library and Archives Canada, Canary, the Tri-Councils, Standards Council of Canada, so on and so forth, just to see how are we fitting into the ecosystem? Are we aligning with your priorities? If we release something that's not consistent with what you're doing, is it going to create unnecessary friction in the environment, and so on and so forth. So we've been just doing soft consultations to make sure that we're doing work that's actually going to be simpatico with other initiatives, and also potentially act as an amplifier for good messages. So the big question here is, fundamentally why actually care about data? And we opened this report with a pretty clear statement about why we would do this. Is that it's simple. Data is an intangible asset, and it has to be valued properly as an intangible asset. An asset that actually has enormous roles to play in R&D, but in the larger economic activity of the country as a whole. And this is a foundational commitment that we make in this report. And in saying that, we also don't just imply, we actually assert that Canada has actually been doing a really not very good job for upwards of about 5 decades in terms of managing its intangible assets, data being one of them. And we pour a lot of money into generating data, and then we're actually not very good at managing it. So the stakes are high in the sense that if you actually want to be a knowledge-based economy or new economy or whatever lingo you like, if you actually don't take these intangible assets seriously, you can be sure that you're actually losing value on a drip, 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 drip basis. And that's what actually has been going on for a number of decades. David Dodge, a few years ago, former governor of the Bank of Canada, wrote a piece actually where he estimated the net economic loss of not keeping the Canadian economy sufficiently digitized that we were matching total factor productivity with the United States. 45 years of essentially falling behind. And so in this case, the data is in. We actually do know for a fact that we have some serious problems as a country in terms of actually handling data. And so, it affects our collective wealth. It's obviously part of our innovation system that we're not well attending to. Data governance actually is really important from the standpoint of boosting science, technology, and innovation performance, especially in the digital world, and especially as more and more of our scientific activity becomes increasingly digitized. So we need to actually shore this up and figure out what we're going to do. And it is crucial to the AI strategy. I think one of the fascinating things that's happened with the LLM, advent of the LLMs in the past couple of years, that people have suddenly woken up to realize, well, the LLMs are cute and kind of fun to play around with, but they're just useless toys if you don't have data to put into them. And so this is actually, I think, starting to make people think that the data is actually the most important thing. It's not the LLM that's the important thing. And I think, for example, you will be able to watch the biggest power play in AI coming this year when Meta actually decides to really harvest all of the data that Meta has. So I think that this is really what's at stake here. And the last thing, and I have to admit, Jim Gadman, former president and CEO of Canary, has emphasized many a time, both at Canary but in his work subsequently, that this is actually a national security issue as well. How we manage data relates to whether or not we actually have Canadian interests protected. And so we have to make sure that not only do we have all of network, but also databases, repositories, them too, they must actually be well managed. So what is limiting our success? Our advisory committee really came up with these issues: fragmentation across data domains, sector and disciplinary silos, lacking or not enforcing consistent principles and standards, right? So like, why is it that we don't actually require fair data for, say, federally funded research? Low national and international interoperability. The low national interoperability part was exposed in rather dramatic fashion with COVID and the lack of consistent data between provinces, territories, and the federal government with respect to public health. International interoperability, Horizon Europe, Pillar 2, requires us to actually have a fair data standard in place in order to be able to work with Europeans. How's that going? Not great. We actually do have, I think, a beleaguered system for digital research infrastructure where we do have suboptimal prioritization of scarce resources. It's anybody's guess where we stand in terms of workforce capacity and skills development around digital research infrastructure, and I think there is glaring need for enhanced security. So the way we did this was we standard sort of government chief science advisor report. You don't really need to read this whole thing through, but essentially what we decided was we're going to think about the organizational context, and then we're going to think about the practice context and try to sort out what we could do to defragment or enhance coherence in those contexts. So like I mentioned before, foundational principle: recognize data as a national asset. Try to find some sort of system-wide comprehensive approach for both primary data collection processes and secondary consolidation and reuse. It's meant not to be a replacement, but to actually be complementary to existing data governance initiatives, of which there are many. We're not in the business of challenging existing organizations' efforts in terms of like their business practices around data, but we did want to actually try to write a report that gave them a little bit of a lift in terms of what they were doing. Obviously want to promote the general aims of open science, and we wanted also the report to terminate with a roadmap. So this is the way that we did it. It is a principles-based approach. It's quite normative in this respect. It really is about what you ought to do, what you ought to consider. So in the organizational context, we have the principle of data centricity, thinking about the data domains or data spaces. We were thinking also about developing some kind of a national focal point to bring the organizations together on the one hand and domains of practice on the other. I'll explain a little bit more about that. And in the practice context, we want to actually develop principles associated with data domain leadership, stewardship principles, thinking about using common tools and metrics around data governance, and then the security piece. I don't really want to read all the way through these, but you can see these are like just the sort of two or three lines each for these principles around data centricity, domains, a focal point, and organizational mandates. In the report, you get the short statement and then an interpretation of it, so it's a little bit longer to spell out exactly what we mean. Same thing with the principles related to practices around domain leadership and stewardship principles, the metrics, and security. In the report also, what we decided to do was, because this is really kind of dry and abstract and it's about principles and data governance and stuff like that, we also decided to put in some vignettes. So short stories about cases in which there actually really is some very interesting work that has been done or is continuing to be done in Canada with respect to data governance. So things like the federated system of polar data search for countries that are in polar regions. The Pan-Canadian Health Data Strategy, which I was a member of, thinking about data centricity as it relates to individual persons and how they navigate their lifelong health journeys and what's required of that. The CADC, obviously a great example of data governance. I already mentioned BOLD and Embrave. And then ocean data. Obviously, we've got a lot of investment in ocean research. You know, the DFO-sponsored ORCA, which is an alliance of infrastructures supported by DFO and others. The Integrated Ocean Observing System, ONC, the new Oceans 3.0 platform, and so on and so forth. Ocean Tracking Network out on the East Coast, and so on and so forth. And then cultural data heritage, which is a combination of a whole bunch of different sorts of things, which, loosely speaking, refers to a lot of the things that are they may actually be artifacts, but they also might be social and cultural data, which are essentially things that you would associate with social sciences and humanities kinds of research environments. So we've provided lots of examples in the report about different aspects of the principles that we were describing in place. So we decided that there needs to be some kind of a focal point. Those of you who have been around the block on this sort of thing long enough will remember that there once was Research Data Canada, which was under the wing of Canary for many years. I chaired its scientific committee. Mark Leggett was the executive director. It was absorbed into the Digital Research Alliance, and absorbed, I mean, it was absorbed and then it was gone. And I think in some respects what we're trying to do is recapture the momentum that RDC used to be able to provide to the broader research community in the country in terms of being able to generate a community of practice, bring people together to talk about data governance issues, and to think about ways that we can actually improve our work. So this isn't really Research Data Canada 2.0, but it is recognizing that there is a gap in our system. And so what we wanted to do was to create this kind of a system where there would be two fora. One of them would be around the domain interests, to think about the data spaces, helping to identify them, helping to work with them on their strategies and leadership, and thinking about the ways that we can actually work across domains and within domains to improve their data governance. And then the forum for organizational issues, interests on the other side is like all of the organizations and funders who support data infrastructures of different types, and all of the vested interests that they have, to get them to come together and try to figure out a more coherent approach amongst those organizations. And the idea was that those two fora then could actually be synthetically brought together in a kind of a project that's got a coordination team associated with it. Maybe it would actually be something that would be horizontally integrated through Library and Archives Canada, NRC, and the Digital Research Alliance. We at the Office of the Chief Science Advisor have said we would kickstart this if people were interested in it, like we would bootstrap it into existence and then pass it off. I mean, we're an advisory body, in the Office of the Chief Science Advisor. We are not a business owner of this kind of stuff, but we do instigate the development of these kinds of initiatives. And at the same time, I think we need some vertical accountability into the higher level of the system. And I've suggested that the deputy ministers table where they're the champions for science and technology would be an appropriate place to report up to for information, perhaps only, but also to seek their guidance and understand where they think data infrastructures are moving. So this was just a proposed structure. I mean, it may very well change. And lastly, we have a roadmap that we're going to develop and I hope be able to implement. We shall see. This is a little bit like the way that the Australians actually developed their national research infrastructure roadmaps, and specifically the things that they have done to actually give the ARDC, the Australian Research Data Commons, the mandate that it actually has. And so we're thinking that the Australian model is actually really quite good. So the idea is to sort of convene the two fora. I think the organizations that I mentioned are actually a lot easier to assemble than the data domains. That requires a little bit of work to think about which ones we should be focusing on. But it could be as simple as some of the major buckets around physics, astronomy, collections as data, like library collections as data, ocean research, maybe computational social science, biodiversity, so on and so forth, health genomics. So there might actually be some kind of like natural kinds that we can start working with. But then there are going to be others, data domains, that are more like ascension data spaces that we have to think about how to cultivate them and bring them forward. That's going to be harder work. It's going to be hard actually to develop the criteria to sort that out, but we'll do that through community consultation. The other thing we want to do in the process of the roadmap is promulgate the idea of a principle-based narrative on data governance. We want to create trusted research environments for data that we don't quite have right now, and I know that the Digital Research Alliance is thinking very hard about these sorts of issues. Obviously, in any domain or data space, we want to have carefully curated, fair implementation profiles so that we actually know how fair data principles land in different domains. And of course, part of all of this is make sure that all of this data is machine actionable, AI ready, whatever kind of language you want to use around that. So this is to advance the mission of creating data infrastructures that are domain responsive, also generic sometimes as well. We do need some fairly vanilla services to the broader community, so we have to provide those as well. And we need to attend to the workforce capacity and skills agenda, which is a very difficult thing to tackle, but we need data stewards all across our system, and certainly across all of the MSIs, it's crucial. And then, especially for today, the main topic here is really thinking about how do we actually reorient MSIs and MRFs to become really data-centric in their governance models. I think to a certain extent they are, but what if it was actually really data-centric and we organized the MSIs and MRFs so that they were actually calibrated to pay attention to data across its entire life cycle. Right now, we tend to think a little bit more about MSIs as being projects because they are competed for and designed around essentially project-based funding, which is maybe not the best way for thinking about research infrastructures and probably not the right way to think about data infrastructures. So just as an aside, I actually had dinner last night with the person who was responsible for creating the MSI program. And let's just say, you work with the tools that you're given. And so project-based funding, project-based approaches were the tools that were given at the time. So there's that. And then the other thing is that we tend to think about MSIs and MRFs as actually being about the facilities and about the co-location of facilities at universities and their management. But what if you actually just turned that around and just said, well, forget about it being a project or forget about it being a bricks and mortar facility with a lot of shiny equipment in it and doing interesting things. What if you just said, this is actually infrastructure to produce data, whatever infrastructure it happens to be, its fundamental role is actually to produce data. And anything that you build, anything you buy, any person you hire, any program of research you bolt onto it is actually only about generating data. That's the raison d'etre for all of this stuff. And everything is subsidiary to thinking about a data-centric model for these kinds of infrastructures. So with that, I will stop. I'll just leave this principal slide up, and I think we will move on to our discussion. Right. So Benoit, your reactions.
Thanks, David. What I did for today's, for my intervention today was to essentially consider perhaps those principles that David presented already, and perhaps hammer a little bit more on them and giving a little more perspective on them and examples of how they can be implemented, perhaps using some of our own experience at ONC in some cases. So the first one is, as you can read on the slide here, is data centricity. I think we can say with confidence that at OceanWorks Canada, for example, this has been the very basic principle from day one. I mean, we were designed to produce data, and so it took a lot of efforts and a lot of emphasis, and it was not always easy to convince people that it was indeed going to take some efforts, and we needed to invest in the data management aspects of what we were going to do. It was not just about boats and instruments that will be providing cool videos for people to watch online. And finally, I think my colleagues here will testify to the fact that indeed, at OceanWorks Canada, you heard this morning from Daniela that we have about 170 employees. I think that 35% and more of these employees are working on the digital side of what we do. That includes all sorts of activities from network management to data stewards. We have like 15 to 18 data stewards-ish, I think. And we have also the same amount of people looking at data quality, curating our data. And so I think this is the sort of investment that is required if you want to consider yourself a data-centric organization. So the next principle is about data domains. And here, I think we have a big spectrum. I'm using the word spectrum here. It was not the word that was used before, but I think I'd like to extend a little bit what Eva presented to us this morning, where she was more focusing on where the data source were sensors and so on. I think the spectrum extends much further, and I want to use the example of the MSIs that we have here represented. So Tanya's Erudi and sorry, I forgot. But that's right, Alliance Publica. You're dealing not with sensor data, but rather with documents. You're dealing with multimedia assets, and maybe in the case of the humanities as well, you can imagine digital artifacts. Those are very different from sensor data. First of all, the sensor data can be real-time in many cases, whereas, of course, humanities are not necessarily, or perhaps exceptionally, a real-time data collection issue. And in between all of these, we've got all sorts of other things that have to deal with, for example, the health data, where it's a mixture of sensor and sample and statistics and so on, and model results and whatnot. And of course, the objectives of all the organizations on this spectrum is to make our data as open as possible and as restricted as necessary, as we always say. And the restrictions have to do oftentimes with the privacy, and certainly the case in the health data, with perhaps indigenous ownership of the data that was collected in their territories, or, as was mentioned by David as well, national security. So I think this is an important one that certainly is recognized by everybody. If I move on to the following principles, the focal point for data governance and the organizational mandates, I think I like very much what Eva presented, the CI Compass, in the sense that this is essentially indeed one of those focal points, representation or instantiation for a number of scientific disciplines that are supported, in this case, by one funding agency. And of course, there would be others, but this is perhaps a great example that could be serving as an inspiration for doing something similar in our case. And then, of course, once we have these focal points and they meet and they come up with ideas and recommendations, the principle for organizational mandates is indeed the implementation of those recommendations. And then that will lead automatically to data domain leadership with the development of standards, workforce capacity, and skills. However, I think we should realize that we don't have to reinvent everything. There's already a lot of great examples that exist around. We should certainly rely on international bodies that have recommended standards, and the Research Data Alliance was mentioned before as a very active group that continues to produce data management standards. And then the same goes for the principal standards to validate data repositories. So you've heard David mention a number of times the World Data System. The World Data System is indeed a club of scientific research data repositories. And by being a member, you basically have to comply to a number of criteria. And basically, they come back to the trust that we should have in these data repositories, as they have to be certified through something like the Core Trust Seal. So then we move on to principles 6 and 7, data stewardship principles and common tools and metrics. Again, if the data repositories, if all our data repositories, even if they remain individually located to you, with your MSI, I think they can try to become certified as a Core Trust Seal organization, and then can become member, if they choose, of this World Data System group. And on data security, I see multiple aspects. We have to remember that data security is not just protecting your data against some cyber attacks. There's multiple aspects to that. And as a reminder, you still have to protect your data against natural disasters. I mean, the fire could break out in your computer center, so you better have something somewhere else that has a copy of it, and your business continuity plan should take that into account. You need to protect data against unwanted access, right? So as we said, we sometimes have to protect the data because of privacy reasons. You want to protect your data and your data systems against hackers and compromising attacks. So that's a different aspect that requires different solutions. And then we have to think about the national security aspects. For example, people working like we do at OceanWorks Canada in the ocean, where we have to share the ocean with the interests of the navies. It's important for us to find a common ground where we create compromises where the data that we produce and make available publicly is not affecting or risking the national security and transmitting key data that would be making our vessels identifiable by foreign powers that may not be so such our friends. So I'll stop here with those remarks. And again, I'm looking forward to the conversation we will have after this session. But the next, I think, is Natalie. Thank you.
Thanks. Natalie?
Yep, thanks. Okay. Which one am I on? This one? Okay, I can just move that out of the way. I'm short, so my whole head's covered with a microphone. Thank you to my colleagues for what you've had to say so far. I'm going to just make 2 points. I'll elaborate them on them a little bit, but 2 main points that touch on 5 of the principles here from the perspective of CRDCN, to put a kind of picture on it with our kind of unique use case. So what I'll look to is principle 1 on data centricity, which is obviously a very core part of the argument, and David made a call for revolution at the end in terms of how we could look at MSIs from this perspective, and also how this relates, data centricity, to organizational mandates and funder roles. I want to bring these two things together using the example of a data domain, or from the perspective of a data domain, which is a key element of the way the report is organized through principles 2 and 5. So CRDCN is a research infrastructure for the social sciences and population health. And this infrastructure doesn't just generate data or use data, it fundamentally is about data. So existentially speaking, I would say data is the infrastructure in our case, which is a little different than some of our colleagues in the room. And I think this is really important to understand in the context of discussions around what actually constitutes a national research infrastructure more generally. And these discussions are happening right now, as you know, in what we're talking about as we aim to define and implement the MRF. And I know colleagues at the table right in front of me are very heavily involved in this. So the major research facilities framework in this country as we discuss this. So I'm going to use a little bit of CFI language here when I make this argument. When data is at the center, then the way I would argue it is that the data becomes a capital asset, right? So David was talking about assets and a national asset. I'm going to use the language of capital asset to make the argument a bit clearer here, which in the case of CRDCN, to me is more important, this capital asset is more important to the functioning of the infrastructure, to supporting the work of the 2,500 researchers from more than 30 disciplines in all the provinces in Canada. It's more important, the data, than the bricks and mortar aspect. Of course, we do have technical infrastructure. We have a new infrastructure that is, I'm not going to give a date, but it might actually be this week, that is almost ready to launch, to turn this into remote access and that sort of thing. That's a huge undertaking. I will not minimize the importance of that technology and the work that goes into that. But by thinking about what we're doing, it really is about the data more than it is the bricks and mortar facilities. But capital assets always need to be maintained. And data, as a capital asset, still needs to be actively maintained. And I think Benoit pointed to this maybe, or David spoke to it as well. There is a significant labor resource to deal with data. And this goes for all of the MSIs. In our case, working with Statistics Canada, the processes of collecting that data, national surveys, administrative data, and so on, of curating it, anonymizing it, preparing it for use by researchers, and all of the security that's involved in that, is a really massive undertaking. So data stewardship is expensive, and it sits alongside capital expenses. Data preservation, which is an element in there, deals with very fragile objects. I used to be more squarely in the world of digital preservation, and there was a kind of running joke that if you wanted to preserve something for a really long period of time that was digital, you should just chip it into a stone tablet, because that's much more secure than digital preservation, which is a harder activity to achieve. Okay, so that was my first point. And my second and last point for the moment is around principle 8, which has disappeared from the slides, but I will reiterate that this is the one that was on security. The need for security that is commensurate with the significant investment in data production. And we obviously need to take this really seriously, not just to protect our national assets from improper use, or a term that's frequent these days is dual use research of concern. So in other words, research that takes place with that what wasn't really intended. But also we have to ensure the security to keep the continued generation of the data. Right? So in the case of the kinds of data that my researchers are working with, there is a national trust that's required to be able to collect that data in the first place. And keeping it secure is a part of the agreement, the kind of national agreement that takes place. So to ensure continued generation, relevance, and availability of the data, the security is also very important. In our case, the data deals with very sensitive personal data about Canadians' lives. So ensuring that that privacy is maintained is central. And this is becoming increasingly more costly to do. And I have seen this, I'm almost 2 years into the role at this organization, and the costs, the way they have gone up for the infrastructure that we're building just to deal with changing cybersecurity requirements are really extensive. I'm not dropping any hints to CFI here, but it's been expensive. So this process is costly, and it's costly because you need new protocols and you need new ways of monitoring. It is not a one-step process. It's an ongoing cost that has to be updated and maintained as the cyber environment changes. So security is really important. But that's only half of my point. The real point that I want to make is that we should not retrench our efforts to bolster and support open science practices because of our concerns around security. And I have heard this conversation starting to emerge. We are in a moment where there are shifting politics, where the ideas of looking inward and protectionism are becoming every headline that I read every morning when I wake up. But we have to remember that the impetus for this entire advisory committee to talk about a national data governance framework, the impetus came out of the roadmap for open science, right? So there is a preceding goal there to open up the processes of scholarship that's really important. So digital security is about managing economic and social risks, but there are also economic and social benefits to open science as well. We need to find that balance. So I think what we need to be asking is, how do we manage this risk while still operating in an environment that can do several things? Still operating in an environment that promotes the acceleration of science through increased exposure to scientific outputs and to sharing of those outputs, that builds on the return of investment of data through reuse and efficiencies, because when we talk about infrastructures being about data, it's the initial generation, but it's also how can that be reused? How do we build on it so that we're not reinventing the wheel? And the COVID-19 case was very clear to everyone that if those efficiencies aren't there, you're going to have 1,000 different groups working on the same problem as opposed to building on the outcomes. And the third thing that we want to ensure is that this process of managing risk and keeping an open environment builds trust. And trust can partly be built through transparency and the effort to support research integrity and all of the rest through that. So those are my 2 points, and I'll pass it on to our final panelist. Thank you. Thanks.
All right, David. Thanks, David. Thanks, David. Okay. So I'm just going to come at this at a slightly different angle, and as you saw, my name was not up there on the working group initially, and I think probably I'm the surprise addition to entice people to come and attend the panel, but I don't know. But I was not on the panel, so my review of the report comes from the outside of the panel, and thank you for David and the panel to trusting me with reading and reviewing the report before it is out. So, but it gives us an outset perspective of what the report is. I'll also acknowledge that I'm not a data scientist and not expert in all areas. But one thing I do maybe a little bit about is related to health data. I've spent better part of the past decade in trying to figure out the challenges and the opportunities around health data. So when I was looking at reviewing the report, I just focused on some of the areas that I could understand, and that was around health data. So I'm just going to provide very quickly, I'll keep it very short, but 3 points where I thought the report did really well in highlighting some of the challenges and the work ahead. And then I'm going to also highlight 3 points where I think we still need some work ahead of us. In terms of the 3 points, I think the report really recognized the urgency of the health data reforms and correctly identifies Canada's health data landscape is disorganized and siloed. It's a long-standing issue. A lot of people who were working in this area, we know about that. The report does mention the Pan-Canadian Health Data Strategy, I think David was part of as well, and the Health Data Charter, which is really important steps towards creating a person-centric interoperable system. The second point that I noticed in the report was in its major strengths on emphasis on shared standards and common tools, which was, I think, under Principle 7. Yeah, that's what it is. It acknowledges that health data systems in Canada remain incompatible across provinces, health authorities, and research institutions, limiting the ability to share data efficiently for patient care and for policymaking. And the third point, the report also acknowledges that we need to align with international standards for health data governance, including it mentions OECD recommendations, open science guidelines, interoperability. Again, something that is relevant to the shared standards and common tools. And the report does a really good job at highlighting some of the challenges or similar challenges around the health data. Where there are still some gaps, and I think David mentioned next steps, and a lot of that will hopefully be covered as we go forward and as the committee takes its works forward, is so it's obvious that the real impact will be in the implementation of the plan, specifically for health data. Some of the challenges that have been reported in the report, we have talked about them for many, many years, and we acknowledge it. But we need a clear implementation plan. How do we deal with it? How do we actually make a difference in moving forward? So, David, again, for the committee and for all of you, one of the things that hopefully the focus will be as to, now that we know and we have succinctly organized this, what are the next steps in actually implementing some of this area? Who will do this? Who will lead this? How will we do this? It's not just about dollars and cents. It's about leadership in this area. It's about actually giving somebody a charge to actually do it and giving somebody the authority to do it. The second piece is, which is recognized in the report, but I think more emphasis is required on the federal-provincial coordination piece. That remains an open question for me around health data. How do we coordinate across our boundaries? I've been in Canada for about 13 years now. Most of my training is in the UK. When I came to Canada, it dawned on me that working in Canada was like working in Europe. That was before Brexit, by the way. So it was working in Europe because each province has their own policies, its own jurisdiction. I almost felt like I was working across colleagues across Europe. So that needs to change, and hopefully what's happening down south will force us to change some of those things, which will be a positive outcome if there's going to be a positive outcome of all of that. And the last thing I would talk about is that I would have liked to see a bit more emphasis on patient-centric data governance piece, especially in the health data area. It's underdeveloped. I think we need to go a little bit more specific on patient rights, consent mechanisms, and ethical considerations. So in general, I think an amazing first step, or I wouldn't even call it a first step. It's culmination of a lot of work that the committee and a lot of people have done over the years. So it's good to have everything in front of us as a report that comes out. But I think addressing some of these things, and the key will be how do we implement some of those stuff. And then there are some other specific, but I think we'll talk about them through the panel. Thanks, David.
Excellent. Well, thanks very much, Benoit, Natalie, and David. For your remarks. You mentioned a couple of times, and it's actually maybe just worth bringing this up specifically. A couple of years ago, Public Health Agency of Canada and Health Canada sponsored an expert advisory group to develop a pan-Canadian health data strategy. I was on that group. It was ably chaired by Vivek Goel, who's president at the University of Waterloo. We had another person, some of you may know on the committee from the Public Health Agency side, Eric Sutherland, who is now at the OECD and works on health and AI from an economic perspective at the OECD. We had in the minister at the time, Jean-Yves Duclos, a champion for thinking about health data. And you had mentioned in passing that in the third report that we developed with this group, we developed a health data charter. And essentially, the health data charter was a kind of digital lens through which to look at the Canada Health Act, which was conceived in analog times. And so we had a 10-point digital health data charter, which I actually wrote. So with my colleague Bartha Maria Knoppers, who's recently retired from McGill University. And the reason why it's actually worth bringing this up is that I think that if you look at these 8 principles here, you might say, well, those are kind of anodyne. Like, who wouldn't disagree with those? That's kind of the point. It's like the FAIR principles. The FAIR principles were actually an assembly of things that people were already doing, but they were put together in a way that made a coherent picture about how to manage data. And our point here is that I actually don't think that any of these are rocket science. They're hard to implement. They're sometimes hard to express in technical terms, but the whole point is actually put these things together in a framework. And we learned a lot by doing the health data charter. So back to this point, which is that it was a principles-based charter that was person-centric, not patient-centric, consistent with national law and Supreme Court decisions, and consistent with the Canada Health Act. But it explains a whole new orientation to thinking about persons in Canada with respect to their health data. So it's worth actually going and looking at this. And implementation is really key. You brought this up. Implementation is so key, and one of the things that we were very fortunate to have in the minister at the time is he liked so much the report that we produced that from August, when the last report was put out in 2022, it was on the table as part of the federal, provincial, territorial health transfer negotiations in November. It was modified slightly, and it is now actually embedded in FPT processes all across the country. And it's making a difference in terms of the way that people are thinking about health data, and it's raising everybody's game. There is a bill about essentially avoiding things like vendor lock-in and making health data liberalized, accessible, usable for the benefit of all Canadians, but certainly for those persons that are actually the source of that data. So these high-level principle things actually do sometimes land in ways that make nationwide differences, and the health data charter is one of them. So I just wanted to give you a slightly long footnote on that one because that's a motivating factor here. Now we're here talking about the CFI MSIs, MRFs, right? So we have 2 questions. These are kind of interlinked questions. I'm going to ask our panel members here to comment on these things, and I think you can sort of think maybe actually about answering facets of each one of them at the same time, depending on how it goes. But the central questions here that I want them to respond to, and then we want to open it up and have a conversation about this in the room more broadly, is what do we need to do? Like we those of us that are in the MSIs or in MRFs, what do we actually need to do to actually have these things recognized and actually oriented towards thinking of themselves as fundamentally data infrastructures? So how do we actually implement data centricity within the MSIs in a way that actually makes a core difference in terms of the meeting some of the objectives that these principles reflect? And so that's how do the MSIs actually think about the way that they govern themselves and describe themselves in terms of their core narratives? So that's the sort of governance at the level of an MSI question. But the other question is, what could we encourage the CFI to actually do to actually make this actually the way that we think about MSIs as data infrastructures? And what would that actually look like in terms of CFI support to existing future MSIs or MRFs or whatever we end up calling them? But what would it actually require programmatically from the CFI to actually make this a reality in a way that actually is a credit to the way that the CFI is actually organizing its own programs and work and contributing to the national scientific landscape? So those are the 2 questions. I think I'll start with you, Benoit, because you said some interesting things, for example, about stewardship, data stewardship at ONC. So, from your point of view at ONC and what you've seen in the other MSIs, like how do you actually be a data infrastructure? What does that actually mean on the ground in terms of the work that you do, and how do you think that could be supported by the CFI? So,
yeah. So I think. Some of the things that we've tried to implement is what you could call a soup to nuts implementation of a data management system. Basically, you care about the data source very much. You know your instruments, the sensors that are producing the data, if that's what you do. or your source of data if you're in the social sciences or the humanities, of course. And then you make sure that they follow a trajectory through your system, a little bit like what Eva presented as well, basically going from pre-processing and data quality control, and then archival, and then maybe a copy of that archive for data security purposes. But every one of those steps will require a bit of hand-holding of the data, as little as necessary, as little as possible, but as much as necessary. And those steps require that you have on the upstream side, basically where your data are being collected, people who look after your networks and look after the source of data and so on. They could be, in many cases, a lot more technical, but as you move forward in the process scale, you get people with different skill sets. The people who are looking at the data from a curation perspective, from a data quality perspective, they have to be domain experts in what to expect from your sensor or from your source of data. The people, and then the next step also is something that straddles the entire process string, and that's data stewardship. And to me, that's the people who do look after the metadata, essentially the description of what it is that you're doing, the description of the instruments and sensors that you use, the source of your data, the description of the life cycle of those instrument-producing data. And this particular metadata collection is what is going to make your data reusable. So in the FAIR, of course, the last letter, R, is to me the most critical one because it requires a lot of work and efforts. This is the reusability. How can you have a third party in 10 or 20 years trust what you've done or even understand what you've done to collect the data if it's not super well described, where all the characteristics of what happened to the data are recorded somewhere in a way that's meaningful, using ontologies and vocabularies that are relevant to the field. So again here, like I said in my brief presentation, we've made a very significant effort at ONC to be, shall I say, maybe obsessive about metadata, thanks to the efforts of one particular individual that we had on the team, and so credit to her for doing all that. But it's now our claim to fame, is essentially by being able to say, look, we've invested a lot, but here are the results, and it was all worth it in the end.
Okay, thank you very much. Natalie, what is your view about, especially since you've taken over the helm of the network, and you've brought a lot of experience from Europe and Digital Research Ireland. You've seen other governance approaches, and what have you done to essentially beef up the MSI that you're working with to actually meet some of these principles? You've alluded to some, but hear more about it.
Yeah, there's a few things. I mean, Naveed said that it feels like almost as hard as working in Europe. I actually think working in the Canadian context across provinces might be more challenging than it is, because there are incentives coming from Europe to make that coordination happen. And we have the incentives here, but you need the two-way thing. In Europe, it's the member states willingly contributing because of the pile of money they want from Europe. And here, there's always this effort to balance between provincial and federal funding, which just doesn't play out as easily, I would say. But that's an aside, because I wanted to speak to Naveed. I mean, in terms of the question, the overarching question of what do we need to do to kind of recognize MSIs as data infrastructures, we already are one. I mean, that's the way we position ourselves. So that's not too difficult a step, I think, for CRDCN to take. But I think what you need to look at is what is the relationship between research and data in your infrastructure. That sounds very simple, and it's often a cyclical relationship. What's the cyclical relationship? Because the data isn't just produced and is stuck out there on a server somewhere and never touched again. It ends up coming back into that cycle. So what's the relationship, and what are the points in that data lifecycle that require interventions? I mean, I can't emphasize the need for great metadata more. That is really key. In fact, I can't think about data without metadata. So I almost thought, oh yeah, good point to mention that, but isn't that, what's the use of it if we don't have it? Because you can't do anything with it. So what are the points in the data lifecycle that require intervention? And how is the research activity that you are supporting and trying to promote and grow and improve and make more efficient and all of the rest, how is that activity supported or stymied by the way that you're managing data within the MSI? And I think asking those kinds of questions can point out the centricity of data becomes very apparent if you look to those.
Okay, yeah. Great. So same questions again, Naveed, and you now have you have at least, a different perspective now that you're sort of out of the MSI world, but you're obviously deep into the Genome Canada world, and so I'm sure that you've started to think of, across those two different domains about data and how to actually make, are you going to make Genome Canada a data infrastructure?
Isn't it all about data, as you said, right from the beginning? So I mean, we laugh, but there's some value to that comment, right, David? Because data being generated and being data centric is important, right? And it in a lot of the domains is the real focus and should be the real focus, right? But I think in terms of when we're talking about MSIs and data and MSIs, and I think CFI has their work cut out because the MSIs are very different. Not all MSIs are the same, not just the size, but the way they kind of interact, the way they function, right? Some of them are small, some of them are big. Some of them produce data, some of them ingest data, some of them produce and then analyze and then data stewardship is involved in that as well. People say data is the new oil, but I remind people that oil is a diminishing resource. Data, the more you use it, the more it increases. So for MSIs that actually try and get some insights out of data, the data keeps increasing in size as well. So when we talk about MSIs, whether MSIs are data-centric or should they recognize that they are data-centric, I think probably a lot of the MSIs will not deny that, but we really have to define what does data-centric mean. What does that mean for an MSI to be saying, we are data-centric and we are all about data? Because some of them, you might be surprised, might not say we're all about data. We produce data, we move it, we give it to the person who as a service provider, and that's my role, and that's it, right? So defining what data-centric means is important. It's important because if you're only generating data, that's your role. There's a different definition of data-centric. But if you're going beyond that, then if you're talking about data stewardship, that plays into data sharing, which plays into data security, which plays into data governance, right? So defining data-centric from a kind of view of data governance is important for the MSIs, and then kind of calculating backwards from the governance piece as a group, what can the MSIs do, and what are some of the FAIR principle or FAIR-like principles that a data-centric MSI portfolio. So that's one thing I would want to bring into the conversation, is that when we talk about MSIs, we should talk about them as a portfolio and not just as and I know they're very, very different, but if you talk about data and data-centric, it really is a portfolio of not projects, but initiatives that are dealing with data. So I'll stop here.
Okay, well, thank you very much. Thanks for those contributions. We have about 20 minutes now. It would be actually really nice to have a conversation and get some audience feedback. It can be comments, questions, accolades, criticisms. Great.
Hi.
Nils Peterson from Glyconet. I'm curious about the intersection between data management and intellectual property, and whether you could talk a little bit about that. Because it seems to me that when you work as a service organization, you provide data to private companies sometimes, and so how do you deal with that aspect of data management?
Okay, that's a good question. Somebody on, guys, any
I didn't quite get the question so well. Can you repeat the question?
Oh, the question was actually, what's the interaction between intellectual property and data management, essentially? So if you have proprietary data, maybe it actually has some formal IP associated with it, then what do you do in terms of managing it? And presumably the question's also about methods for licensing it.
I could just quickly.
Yeah, just quickly.
The biggest tension between open science and data security, or not data security, but national sovereignty, is around IP, is around how do we then kind of inform outcomes from the data that is still useful for where it's produced, whether that's a country or whether that's a province or a project or an institution. Mm-hmm. And that's a difficult balance to we talk about open science all the time, but Mona actually during the pandemic really well talked a lot about the fact that open science is great, but we also have to look after ourselves, and we also have to look at national security as well. So that tension, I don't have an answer. I'm just saying that's a great question, because there's also this tension between open science and IP. I have my personal opinions, which I wouldn't indulge in here, and we can talk about it separately. But I think that the tension is always there, and there's a balance. There are ways to handle it. There are ways to do it. We're making data open science with, giving people some head space, some headwind, things like that. But there's always that tension.
I'll just make one. Yeah, go to the mic, and I'll just make one other comment about this as well, which is that there's a respect in which the language around open science is actually very, very good in terms of it's very motivational. And it sets out aspirations for how we produce and share, use knowledge, but it can actually muddy the waters, I think, when you're talking about the sorts of things you were referring to, which is why I think that the FAIR principles are a much better acronym, because FAIR data can be open, but it isn't always, because under the A part, accessibility. You should be able to find data and data sets, and you should be able to be exposed to the underlying metadata for that data. So that should all be discoverable, but whether or not you can actually access the data is a different question, and there's conditionality associated with it. Sometimes it's just an open data platform, right? Like Oceans 3.0. You can just get a username, log in, and look at ocean data produced by Ocean Networks Canada to your heart's content. But there are other cases where it will be restricted because it's personal, identifying health data associated with risk. So access conditions prevail. And you may actually have to have in a management regime, not transfer of data, but data visitation, as opposed to moving data around. And then in the case of proprietary data, especially when there's IP associated with it, I mean, a lot of the way that just ends up being handled is, especially in negotiated partnerships, you actually include that as like foreground or background IP when you're actually creating a deal or building a research partnership with private sector and public sector entities, in which case it is just managed up front. It's like, yes, we actually have this data about these flight systems. Boeing, you might be interested in them, right? And then it's done up by contract with NDAs, but it has to actually be managed in those cases contractually, not just as a matter of sort of data management. But that's where stewardship is super important, because you need people to actually understand how to navigate all of those layers. Benoit, you had
just a quick comment here. Indeed, IP protection is important. It's kind of a national asset as well, of course. In our case, what we've done, of course, we're trying to be open as much as possible, and most of our 99% plus of our data is open to anyone all the time. But in some cases, because we want to be supporting Canadian industry in particular, and particularly Canadian industry that produces instruments and sensors that would be helpful to be used underwater, they sometimes want to establish their new product and verify that it works properly. And so what we do, we establish a contract and agreement with these vendors with their future product and test it on our network. The data then is protected for a while and protected until the owner of the instrument decides it's okay now to release it because we're happy with the results. And so we have perhaps a temporary restraint on the data accessibility for the IP protection, in this case, of a Canadian company willing to put their system to the test.
Okay, great, thank you. Over to you.
Thank you. Brian Neff, I'm Associate Vice President of Research at Western. For my question, I just add too on proprietary is OCAP is also an important principle to bring into data ownership management. My question is, so CFI is a big national organization, and we're fortunate to have David Tweddle with us today from DRAC, which is also a big national organization. Has there been conversation around mandates, staying in lanes and working together on these issues?
Takers on the panel?
Me again. So the working group did talk about that, and I kind of alluded to it in my report of the working group. We've had some conversations as on behalf of CFI with DRAC, and I think it's not so much in staying in lanes, because I think we are all very Canadian and we'd like to expand the lane. If there are two separate lanes going in the same way, we expand it into one. So we're very, very good at that. I think it's more the articulation or the definition of what the mandates are, right? And I've had very frank conversations with my colleagues at DRAC as to, as a community, we need to understand what DRAC can and cannot do. They're not the answer to everything. On the other hand, there's a lot of things that it makes sense for them to do as a national organization. What is that, right? So defining that, I mean, it is a lane, as you say, but maybe it's on a wider road. Defining those responsibilities is, I think, key to this conversation as to how CFI and DRAC and the MSIs and Genome Canada will plug my organization and others. We can all work together. But until we assume that there's a certain role that DRAC should play for the MSIs, and DRAC assumes that, oh, this is not what we do, that conversation or that moving forward will be very, very difficult. I'm just being very honest and open here. I think once we realize what our areas of work, so to speak, is, then it will really move the conversation forward. And there's a lot of positive conversation around that between at least the working group and DRAC, Genome Canada and DRAC, and I'm very sure CFI directly in DRAC as well.
Yeah, I mean, to answer your question, I'm sure every MSI is having conversations with the Alliance, right? And the Alliance did come into our working group, and you consulted them as well, so that's happening. So I don't know if it's about staying in lanes, because to stay in the lane, you need to know what the lane is, and this is just re-emphasizing what Naveed said, and I don't know that those are clearly drawn. So I guess the key point is that if we're moving forward with something like this MRF framework and hopefully trying to expand that in a way that encompasses the broad portfolio that we require to do the diversity of research in Canada, that those conversations are happening with the Alliance always at the table and vice versa, right? So I think it's the coordination between those, because it will come down to, you can talk about what lane you want to be in, but if you don't have any money for it, then what are you going to do, right? So where is the funding going to come from? And in terms of those two and other potential players. They're not very satisfactory answers, but I think it's because that's in process.
It's not a satisfactory situation.
Yeah, well, no.
Yeah, exactly. Paul, and then David.
Yeah, thank you very much. David and colleagues, I think this governance framework is a great thing that you've done. I think that's a real help, but ultimately, you know, moving from governance down into management and operational issues, you know, what are the barriers to these lofty goals? Mm-hmm. And one of the problems I see from being in the data trenches is the MSI program provides about 40% of the revenue to the facilities. Yeah. If you were to, and the other 60% often has to come from competitive grants. If you said, I'm deeply interested in curating data, but I'm not going to collect any more data on any problems, I can assure you it won't be funded. So there's a tiny amount of our budget that's available, and Natalie, you raised the fact that these are capital assets. The data that we have collected is, you know, cost a lot of money. But I see this tension in the way the system is set up, the tension between fresh data collection and the ability to properly curate those resources that we built up perhaps for a decade. And we certainly, I don't know of any national strategy that would try to identify strategic resources for our country to say that we're real world leaders in this domain. These are the resources that we must protect as a nation, that we must invest in heavily. I tried in the latest CFI-IF competition to request an aliquot of funding for data curation because, as many of us note, sensor technologies have advanced hugely, the flood of data, and the answer was data curation is not an eligible expense. You know, I think that's a mistake if we really truly do believe that these are data assets, capital assets. And I guess, Natalie, a question to you. How do we value these data assets? Because data item A is not equal to data item B. You know, yeah. How do we get to that point, that valuation, and then properly resourcing those assets?
I think, I mean, I don't have an answer to that, but I'll speak to it in the sense that the second question you asked is what can CFI do, right? So if we extend the argument around looking at data, not just the actual data sets, but their curation through creating rich metadata so they're useful to anyone and all of the rest. If we look at that really centrally as a capital kind of cost, then how do we reframe the way that granting categories or funding mechanisms recognize that kind of thing, right? Accurately capturing the costs around the management of data is a really big challenge, but there have been many efforts to address that. There's been entire European projects dedicated to that in different domains to say what is the cost of curation, what are the models we can look at. So it's hard, and it always feels like a moving target to be able to capture those costs, but I think putting some effort into being able to define that for your organization is useful. And then how does that then relate to the funding mechanisms that are available? Because there's often different funds for capital costs, right? And then there's operating costs. And then we look at human resources costs, but they're not actually entirely separate things, right? You could have capital funding to create the infrastructure that you need, and then I'm arguing again the data is part of the infrastructure, but then you have all these other processes that need to take place for that to be meaningful, right? So, I mean, I completely understand, and it's not uncommon at all, these funding mechanisms in the ways that they're divided. We see them all over the place. This is not a particularly Canadian thing or particular to MSIs, but we're shifting the way that we think of the kind of products of science and the things that we need to do it. And this is, I think, where the data centricity comes into play. Mm-hmm. So how do the mechanisms need to adequately shift to reflect that, I think, is the bigger thing. But it's not an easy answer.
Yeah, thanks very much for that.
Yeah.
Just one minor follow-on, David, if I might.
Sure.
And that on the operational front, now getting really down in the weeds. In the last 2 weeks, I've received a number of messages from Canada's Digital Research Alliance basically saying that key parts of the platform are down, or wait a month to get your data analyzed. you know, if we're talking about governance frameworks and we don't have the capacity to deliver analytical support or storage in our national platform, that is a huge problem. I mean, and it's been a long-standing problem.
Yep.
We're hoping that Digital Research Alliance can do much better than Compute Canada, but you know, I know it takes time. I know infrastructure is being embedded, but it's a real problem for us. We're having to go to the commercial cloud because we can't count on Canadian compute capacity. That's wrong.
Yeah, agreed, fully agree. Well, so you're going to fix
Good
everything.
timing.
So that was convenient.
It's up to you.
All right, I actually wanted to, okay, first of all, David Tweddle, Digital Research Alliance of Canada. I wanted to spool back to some of the earlier comments. And those first four principles in particular, data centricity. So we've been trying over the last couple of years to really think this through and shift the conversation away from a compute-centric view of the world to a data-centric view of the world. And I think many of you have heard me say that before, or heard my colleagues say that before. We've been saying it fairly quietly, so we now need to start saying it more loudly so that everybody sort of gets the message that we're trying to change this view. I don't want to dig into the specifics of the hardware refresh right now. We can talk one-to-one later on that, but we are actually refreshing all of the 5 data centers across the country. And that takes time, and it's got a lot of moving parts, and it's a little ugly sometimes, but there is a lot of work in progress that's going on right now on that topic. But in particular on the data centricity, there's a lot of ongoing conversations, and we're really trying to move into that direction.
Right. So, well, and I think that's, I think actually that shift, and of course that is actually going to bring us in alignment with what's happening in Europe as well, and make us a good partner in the Horizon Europe endeavor. But I think that understanding, and I think this is part of what we need to collectively work on through perhaps the roadmap exercise that we'll be undertaking with following this report, is that we actually now need to think about how we actually articulate that vision of data rather than compute-centric approach to digital research infrastructure. We need to be able to actually port that into the thinking of CFI and the MSI program, but equally into the other funding agencies and the partners to actually essentially shift the perception a little bit, because I think it will, if done correctly, I think it should actually be able to identify some of the now seeming irregularities about what are eligible costs, as you were pointing out, Paul, that, yeah, we are expected to use these infrastructures to generate all this data and do excellent scientific work, but if you can't actually have resourced the kinds of expertise that you need in-house to make that actually happen, your project is already kneecapped effectively. And this is this human factor part is really challenging.
I just want to add to that, because everyone's looking to the Alliance to have the answers, and I know there's a lot of pressure on you guys for that. And maybe that is the way, the resource sharing through the Alliance is the way to go, but maybe there are ways that the MSIs could be working together for economies of scale. That's what we want. We want economies of scale in some way, shape, or fashion, so that it's not 1,000 different repositories trying to deal with all the different little data bits. And so another thing that maybe CFI might want to take a look at, or we collectively as MSIs want to look at, is are there different roles that we could play that could help support one another in this kind of data-centric ecosystem for the MSIs. So, we're looking at CRDCN a lot around fair data and how do you manage fair data in a sensitive data environment, which has its own challenges, because the open part is off the table, right? That's not going to happen. But what can you do? Coalition Publica provides a diamond open access platform for tons of publications, so they're doing a lot in the space, that element of open science. Mm-hmm. Are there ways that we could share that expertise with one another in some kind of structured way with resource to it as well? Because I'm not going to be able to do all of that on our existing resources, right? But if we're looking to build something collectively, there's different places that it could sit.
Yeah. You have a follow-on, but maybe Benoit, if you just have a few words about this.
Continuing on perhaps on one part of Paul's comment and what you just suggested, Natalie. You raised the interesting point of the growth of our data archives and the need to curate them, right? We're collecting more and more data. Some of us has been around for like 20 years or so. And indeed, the instruments that we're using produce more and more such data. And how do we deal with that? By not also exponentially growing the staff complement that we need to support all these things, all these data collections. And so one of the things that we've been trying to do at OceanWorks Canada was to look at a way to improve efficiency internally by having and leveraging tools such as machine learning, for example, that would help us with dealing with the increasing amount of data, the exponentially increasing amount of data. And those tools can perhaps indeed help our staff, existing staff, to deal with those questions by looking at data quality questions, by looking at how to improve the calibration and things like that. So these are things that we should keep in mind as potential solutions to look at or to alleviate the need for continuous growth, which of course CFI cannot support and nobody can support ad infinitum.
You had another follow-up, and then we'll close the session?
Sure. All I wanted to say was, if you've got anything on your mind, send me an email, give me a call. Happy to hear from people.
Great.
That's how we can help. All right.
Yeah. Well, that's what we need to do. Well, thank you. First of all, thank you to Naveed, Benoit, and Natalie for their contributions on this panel, but also Natalie in particular because she had the foresight to actually develop this panel and to have this conversation here at this workshop. So thank you very much for getting us initiated to do this in the first place. So thanks a million for that. Thank you for your attention and the questions. I hope that this discussion has actually sort of raised your view about the importance of thinking about data governance in the MSIs and beyond the MSIs. I think it's tremendously important. It's, I think, the bedrock of what we're doing, and I think we could all do it a bit better and to do it collaboratively as well. And one last final remark is that International I Love Data Week, or International Love Your Data Week, is next week. So do something for your data next week, and then think about your other loved ones. Okay, thank you very much.